Unfortunately, there were some technical difficulties, and I did not record this successfully as I was writing it, but I'm still going to walk you through problem 50. And in problem 50, it's chapter 26, there's a projector and a converging lens, and they ask how far from the lens must the screen be located if the slide is placed 108 millimeters from the lens. So here's the setup. We've got a lens, here's a slide, I put the focal lengths on here, and here's some image that's going to form. It's a converging lens, and when we're outside the focal, light will go in parallel and then out through the focal, and then there's the one straight through the middle, and as expected, they converge, and we get a larger inverted real image, and that's where we need to put the screen, this distance from here to here. That'll be our image distance. Put the screen there, we'll see an upside down arrow. Now they asked for the answer in meters, so at the end we'll have to convert, and probably, no, actually that's good. Part B asked for millimeters, so all of this is fine. What was given was the focal length, the object distance, which is the slide. Okay, so we've got the slide here, and then the lens, and then you put the screen. The light from the slide has to hit the lens to come over here and then hit the screen. And we're looking for a DI. So all of this stuff right here was given fairly straightforward in the problem. And now we apply our 1 over F equals 1 over DI plus 1 over DO. And it is plug and chug. So we have 1 over 105 millimeters, that's the focal length, equals 1 over DI, that's what we're trying to find, plus 1 over 108 millimeters. And when you solve for the DI, if you had this set up, just make sure that you're actually solving for DI and not 1 over DI. So get this as a decimal since you have a calculator, subtract this as a decimal, and then take the inverse of whatever you've got to get 3.78 times 10 to the third millimeters, or 3.78 meters. So this distance from the lens to the screen, that'll be our image distance, has to be 3.78 meters. Part B tells us that we have a slide that is 24 millimeters by 36 millimeters. So they've given us the dimensions of the slide. And traditionally, you do like length by width by height. So I'm calling this the width and the height of the slide. If you mix those two up, it is okay. They would specify, I think, on the AP test which one is which, or it wouldn't matter for scoring purposes. And now what we're really talking about here is that this image, based on the ray tracing, we know is going to be bigger. Okay, it's going to be a lot bigger. So it's magnification stuff. We're trying to figure out how tall is this image. And then also, since we're not just talking about the height of the slide, we're also talking about the width of the slide, we'll have to do the magnification stuff twice. I'm going to start with the width, 24 millimeters, and that is what I'm going to use as my height of my object. So here's the magnification equation, and you should, before you do optics problems, always make sure you know what all the signs mean. For example, we have to have a negative here for everything to be consistent. And sometimes things are negative, like our focal length. This is a converging lens, so it's positive. But if it was a diverging lens, our focal length would be negative in our equations. And those signs do mean something. Or if we have an inverted image, our HI is negative, that kind of thing. Review that stuff before you're doing questions in optics to make sure you got the signs straight on what they mean. Assuming that, we'll go ahead here and plug in. So we have negative DI over DO equals HI over HO. And the DI we found in part A. So we know we're over at 3.78 times 10 to the third millimeters. Long as you keep all the units the same in these equations, you're fine. So I'm going to have this in millimeters. Object distance was given in the original question, still 108 millimeters. And our height of our object, which is our width here, and if you don't like this, I'll tell you what you can do in a second, is 24 millimeters. I basically just turned the object on its side to be able to figure out how much magnification. If you don't like this, what I'm doing here, you could start with the height and get the magnification, then just use the magnification to figure out what's going to happen to the width, what factor things change by. That would be perfectly fine if you don't like this, where I'm taking this slide and like being like, okay, the width turns into the height kind of thing. At this point, just take this, divide by this, multiply by 24, and you will get, sorry, again, solve for HI here on your calculator, and you'll get negative 840 millimeters. The negative makes sense because we have an inverted image. However, when we're talking about the dimensions of something, we don't really need the negative. There's not a negative dimension. So we'll have 840 millimeters by something. And it's bigger. That's good. It's a lot bigger. That's good as well, because we were pretty darn close to the focal length, so I would expect a really large image. Similar to our candle lab we did with the concave mirror, when you got that candle close to the concave mirror, that's when some groups found upside down candles that were a couple feet tall. And our original width, again, was 24, so that's a big increase. Now you do the same exact process again, except for the height. So same equation that we have here. So we got our DI that hasn't changed, our DO hasn't changed. The only thing we're modifying is now we're saying the height of the object is 36 millimeters. Solve and you get negative 1260, 12,008. Let me check here. Did I mess up when I copied over? 1.26 times. So we should have, this is right. This got an extra zero somehow. So 1,260 millimeters is our height of our image, which that actually was our height this time. That was our new height, okay, or our height of the image. And there's our dimensions. And yes, it is much bigger. And that's a good thing because you're talking about a projector here. So if you have a slide and some lens and like a little projector unit and you put a screen out there, you expect the screen to have a much, much bigger image. That's why you have a projector. And this idea of this magnification of the image is used in modern day projectors as well, not just slide projectors. And some of them allow you to focus. Well, they all allow you to focus, but some also allow you to change the image size at this location by varying the focal length. They have optical adjustments, the more expensive projectors. That's it.